Hello students, and welcome to part 2 of this video. In this video we are going to do an additional example of defining a sample space, and then we are going to summarize the lesson. For this example of defining the sample space, which means to show all the possible outcomes, we are going to be talking about a campaign for class officers. That's when you vote for your class officers. So there are 3 people running for vice president: Abigail, Ben, and Charlie. 3 people are running for vice president: Lisa, Monica, and Nathan. 2 people are running for treasurer: Ralph and Susan. So you can see that there are 3 choices being made about the campaign for class officers. This rules a chart out as a possibility for showing the sample space because a chart can only show 2 choices. So our only options are a list or a tree diagram. Now, because there are 3 choices for vice president, 3 choices for president, 3 for vice president, and 2 for treasurer, we know that the fundamental counting principle says if we multiply these, we'll know how many options there are, how many items are in the sample space. So 3 times 3 is 9, times 2 is 18. So we're coming up with 18 different possibilities. Decrease text size here because it's going to be 18 possibilities. So let's start listing what we think could happen. Well, Abigail could win president, Lisa could win vice president, and Ralph could win treasurer. So I just picked the first person from each set. Well, even if Abigail and Lisa won, instead of Ralph being treasurer, Susan could be treasurer. Maybe Abigail still wins, but Lisa does not, and Monica does, and Ralph wins treasurer. I'm going with a strategy. The first person, the first person, the first person, first, second, first, second, first. That's what I've listed so far. So we have Abigail, Monica could win, and then Susan. Or maybe when Abigail wins, Nathan could win. Now I'm going to the third person. And Ralph could win treasurer. Abigail could win, Nathan could win, and Susan could win. Now look at my list. The first person is always Abigail. There's 2 for Lisa, 2 for Monica, 2 for Nathan, and then they alternate Ralph and Susan, Ralph and Susan, Ralph and Susan. That's because I have a strategy. Now, let's look at what could happen if Ben would win. I'm sorry about that. 1 second. Let's look at what could happen if Ben would win. Well, we could have Ben win, and Lisa win, and Ralph win. Ben, Lisa, and Susan. Ben, Monica, and Ralph. Ben, Monica, and Susan. Ben, Nathan, and Ralph. Ben, Nathan, and Susan. Notice again we have 6 times that Ben could be in a combination with different people, and you still see the same patterns. Okay, let's look at the last option, which would be if Charlie would win. So we could have Charlie, Lisa, and Ralph, Charlie, Lisa, and Susan. We could have Charlie, Monica, and Ralph, Charlie, Monica, and Susan. And last, we could have Charlie, Nathan, Susan, Ralph, and Charlie, Nathan, Susan. Again, showing those 18 different possibilities. Now, that same list can be shown as a tree diagram. we would again be showing the 3 choices. We would list them at the top of where we want our tree diagram to be. So, if we want to think about our first choice is for president. So I would write president here. Our second choice is for vice president, and our third one is for treasurer. Now, for time's sake, I'm going to abbreviate each person's name. I'm going to use an A for Abigail, a B for Ben, a C for Charlie, an L for Lisa, an M for Monica, an N for Nathan, an R for Susan, an R for Ralph, and an S for Susan. So I want you to think about the choices that I have for president. I could pick Abigail, Ben, or Charlie. If I pick Abigail, I still have 3 choices for vice president, which is Lisa, Monica, and Nathan. If I pick Ben, I still get those 3 choices, Lisa, Monica, and Nathan. Still yet, if I pick Charlie, I could pick Lisa, Monica, or Nathan. If I pick Abigail and I pick Lisa, I could still pick Ralph or Susan. Same thing for every other choice. I have Ralph or Susan despite who I choose for president and vice president. As you can see, a tree diagram takes a lot of space, so spacing is important. You can see I'm running out of space. Remember, a tree diagram shows all the paths of choices that one person could choose. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are still 18 different options for class officers. 18 different combinations. Now, let's summarize what we've learned. Probability is a fraction, decimal, or percent that describes how likely something is to happen. There are 2 types of probability, theoretical and experimental. Probability is always a number between 0, which means impossible, and 1, which means certain. We could also say that probability is between 0% and 100%, synonyms for 0 and 1. A sample space is all the possible outcomes of an experiment. To define the sample space means to show all the possible outcomes. The sample space can be defined or shown 3 ways: in a list, a table, and in a tree diagram. We will practice all these skills in class.